Okay, so today we're going to talk about ions. Okay, we're going to talk about monatomic ions and polyatomic ions, and we're going to talk about naming them. So, a monatomic ion. Well, what does that mean? Well, what does mono mean? Mono means one, and atomic means having to do with atoms. So, a monatomic ion is an ion or charged particle with only one atom. Okay, so let's look at some examples of monatomic ions. You might have H+, you might have O -2, you might have chlorine -1. You might say, well, how do I know what these are? How do I find them? If we remember our periodic table from the previous notes, we added the plus sign, because we're going to lose 1 electron, we're going to lose 2 electrons, we're going to lose 3 electrons, we're going to gain 3 electrons, we're going to gain 2, and gain 1 electron to make those ions so that they can get closer to the noble gas configuration. So that is how we'd find them. Or we could look at our ultra cheat sheet, common ionic states of elements, and consider any single atom that has a charge on it would be a monatomic ion. Alright, so example of an ionic bond with monatomic ions might be calcium oxide. We know that calcium would make a +2 charge and oxygen would make a -2 charge. So if we were to do our crisscross method, we would have actually gotten Ca2, so calcium 2, and oxygen 2. But we know that we can reduce those. And so just as kind of a review, I don't think that we put that in a video yet. As a review, we know that the reduced version is called the empirical formula. And the not reduced version, or the way it actually exists in nature, is called the molecular version of the formula. So to kind of push forward a little, what do we call this thing? Well, naming ions is actually extremely simple. The first thing you do is you say the first element, you say the cation's name. So in this case, it's calcium. And then you say the name of the element, of the second element, except you change the ending to "ide." So this one would be oxide. And we'll write those rules down here in just a second. But let's put a definition on polyatomic ions. So if monatomic ions are ions with only one atom, what does poly mean? Poly means multiple. So multiple atoms in an ion. So a polyatomic ion is a charged particle, because it does have more than one atom, with more than one atom. Alright, so what are some examples of polyatomic ions? Well, some common examples might be hydroxide. So it might be OH and has a -1 charge. Another common example might be ammonium. Ammonium has NH and it has NH4 and has a +1 charge. Let's talk for just a second about 8 and 8. Okay, so you might have ClO2 and has a -1. That is chlorite. You might have ClO3 and still has a -1 charge, and that is chlorate. You could also have ClO4. That's called perchlorate. And you cannot see what I am writing. And it's called perchlorate. You can also have ClO with still a -1 charge, and that is hypochlorite. What do those endings have to do with? Let's make an observation. What changes in each of these? The number of oxygens, right? So it is a relative association. Hypochlorite has 1 oxygen, chlorite has 2, chlorate has 3, perchlorate has 4 oxygens. There are other ions that have ites and ates at the end, but you need to know that ite is less oxygen, and ate is more oxygen. Okay. Alright, so we can see the names of these polyatomic ions. And let's talk a little bit about naming. We did a practice naming of calcium oxide up there. But let's go through the steps for naming an ion, or an ionic bond, ionic compound. So, of course, the marker is going to give out. We're going to say naming ionic compounds. The first step, say the name or write name of the cation. Ionic bonds are pretty simple, because the second step is say or write the name of the anion. So that's it. We know because of the charge of these ions what their ratio would be. So let's do some examples, some practice. You have a practice sheet in the lesson on Canvas, but we will do some examples right here. And so we'll start with this formula. Well, the cation is copper, because we know that this element right here is copper. So we're going to, the first instruction, say or write the name of the cation. That's copper. Now, copper does present us with a little bit of a complication, because copper is a transition metal. So we need to know which ion it is formed from. We remember that on our cheat sheet we had the copper ion could be a +1 or a +2, so we need to know which one is it when we name it. And the way that we do that is we rewind the crisscross method that we had before. So we take the subscript from the anion, put it back up as a charge, and the subscript from the cation, put it back up as a charge. So we know that this had to be copper 2. And we know that we can show that with Roman numerals in parentheses. So we have copper 2, and then what is that? Well, this is one we'll probably be memorizing very shortly, because it's very common and we are going to use it a lot. So we had NO3. We look at our cheat sheet, we have NO3 right here. The name of it is nitrate. So notice that ite versus ate here. Nitrite has 2 oxygens. Nitrate has more, so it has 3, so that's why it's the 8. So it is copper 2 nitrate. Okay. Alright. Let's go ahead and look at another one. I want to say the name, but that's the whole point of what we're talking about here, is naming this thing. So we'll look at this example, this formula. We'll see the, well, good grief, what is that? We have to find out on our periodic table, right? We should have this memorized, but cadmium is Cd, and we know that it is also in the transition metals. Okay. We know that Cd is at the end of the 4D block. So we know that it is probably going to form a +2 charge. Okay, we can guess that because the 5s electrons would be lost. Those are the ones in the outermost energy level. And then we can confirm that by looking at our ultra treat sheet, and we know that it is in fact a +2. And it only has one ion that it forms. So we know we don't have to worry about the Roman numerals there. So we can just say the name, cadmium. And then PO3. Let's refer to our names. PO3, okay, right there is a -3 charge, and it's phosphite. Phosphite. Okay, so that is it. You say the name of the cation, say the name of the anion. So there's two. Okay, let's go with the opposite direction, though. Let's go with some examples of giving you the name, and you have to come up with a formula. So let's go bismuth hypochlorite. We will just make it a complicated one for our examples. So first of all, if we remember the rules, say the name of the cation, then the anion. Well, we know that this is bismuth, so that is a monatomic. We know that that's on the periodic table right here, bismuth. And if we go straight up, we would guess that it'd be a -3 charge, but we want to remember bismuth is a metal. So it's going to be a cation. It's going to be something else. Now, we are going to assume that it is +3. We could also go back and check our common states chart. Bismuth, it does make a +3, and it does make a +5. So we don't really know which one we're going to use here. Well, let's look at both of them. It's always better to do more work than not enough work. Says every adult. Never mind. And then hypochlorite. Hypochlorite, let's find it. Here is our chloride, or hypochlorite is ClO with a -1 charge. So that is a polyatomic anion. And so when we look at we're trying to find a formula, we use these polyatomics. We could probably go ahead and put the parentheses around them, because that charge goes for the whole polyatomic ion. We are going to crisscross. So we take the charge of the cation and make it the subscript of the anion. We take the charge of the anion, make it the subscript of the cation. So for our first option, we might have Bi, and that would be a 1, so we don't have to write it. Then we need parentheses, ClO, and the 3 would go outside the parentheses. That's hypochlorite. If we put the 3 inside the parentheses, that would only apply to the oxygen. Our charge would not be neutral because bismuth has a +3, and we need 3 of those -1s. And we would have a different polyatomic anion because ClO3 is chlorate. Still has a -1 charge, so we would not be satisfying bismuth +3, but we'd have a different name. So we want to be really careful to use our parentheses correctly. And for the second option that we might have, same concept. Charge goes to subscript, charge goes to subscript. So we could have Bi still a 1. We need parentheses to close in that polyatomic ion, and we'd have a 5 there. All right. Let's go ahead and do a couple more. Okay, because these have a few little things about them. We'll do iron iodate. iron iodate. Well, we know iron's Fe. And iodate, it's not iodite. So if it were iodide with a D, it's not iodide. So we know that it's not the monatomic iodine atom that has become an ion. So we need to look for iodate on our polyatomic chart. Iodate is right here, and it's iodine and 3 oxygens. So we can, I'm going to make that look more like an I. And it has a -1. I'm going to go ahead and put the parentheses around it so that we enclose our polyatomic there. Iron, we know, could make a +2 or a +3 charge. So we're going to have to do the same thing that we did before. We have 2 options when we crisscross our charges. And so our formula might be iron and 2, or it could be iron with a 3. Now, how would you know the difference? If this name were written correctly, it would say, this one would say iron 2 iodate, and this one would say iron 3 iodate. So those Roman numerals help us to know which one we're actually looking at. Alright, let's look at one more just for fun. Ammonium tartrate. Now, none of that's on the periodic table. So we are going to look for polyatomic ions. And if you remember, we just have the 1 positive, the 1 cation, NH4+, which is ammonium. So that's good. And then tartrate. Tartrate is not actually on the list that I gave you. So we had to add tartrate. Tartrate is C4H4O6 and a -2 charge. So that's a lot of stuff going on. C4H4O6 -2. Shoo-wee, that's a lot of stuff going on. So we're going to put parentheses just temporarily around our polyatomics to make sure that we do not mess them up. And take the charge of the ammonium, put it as a subscript of the tartrate, which is just 1. So we won't actually need our parentheses on that one. Then we're going to take the charge of the tartrate. We're going to put it as a subscript for the ammonium. And so we will need the parentheses for ammonium. So let's go ahead and write that. And we need those parentheses because we need to put a 2 outside the ammonium. And then we don't need the parentheses for the tartrate because it's just going to be a 1. Okay? So we came from this name and we just found what they were. And we figured out what their charges were, so we knew the ratio of these different ions to each other to make them become stable.